In the 4.2, where we're going to work on building a scatter plot and finding the best fit line all by hand. So here we have a set of data, hours of video games per week, and your grade point average based on how many video game hours you're playing. So the first thing you want to do is you want to build your X and your Y axis. You want to get these labeled. Well, since your first column on the left, that's traditionally your X column table, this is your Y. This axis will be the Y for the grade point. This will be our X axis for the hours of video games per week. Now, one thing I want you to notice on my graph here is there's a little squiggly breakdown here. And the reason that's there is because you don't see too many GPAs really close to 0. Now, the highest GPA you can have is 4. So what I would do is I would say the very top line up here, let's make that 4.0. And since we have a lot of decimals here, I opted to count down by 0.1. So here's 3.9, 3.8, 3.7, 3.5. And all the way down until I got to 2.0. And the reason for the break is because there's no data in here below 2.0. So they usually cut that part of the graph out. Now, when that happens, it's very important to understand you cannot make visual comparisons of your graph because part of the graph is missing. You cannot make visual comparisons. And what I mean by that is if the slope looks like it's going downhill or uphill, in this case it's kind of looking like it's going downhill because my x's are increasing and my y's are decreasing. So what I'm saying here is that the slope, the physical slope of the line might not be true because there's part of the graph here missing. And when we plot the points, and I'll kind of show you what that means. All right, on the bottom, counted by ones, there's 5, 6, 7, 8, 9, 10, so on and so forth. Whoops. Labeled my axes, and now we'll get ready to go ahead and plot points. So 0, 3.5, 0, 3.05. And again, you just need to put this point somewhere. That's why I'm kind of using big points here. 1, that's, if I made them too small, they don't fit where I want them. So yeah, they're really covering up a lot of space. That's fine. 2 and 3.24, 3 and 2.82, 3 and 3.19, 5 and 2.84, 8, 2.31, 8, 2.54, 10, 2.03, 12, and 2.5. And again, if I went faster than you, go ahead and pause it, get caught up, and once you're done graphing, replay it. So now you may be asked to find the equation of the line using certain data points. This is not the best way to find your best fit line. In this case, the author says, well, let's use the first point and let's use the last point, and we'll call that our best fit line. Well, the first point is at 0, 3.5, and our last point is at 12, 2.5. So it's basically these 2 points right here. So if we found the slope using those points, 3.5 minus 2.5, and second y, 2.5 minus 3.5, and 12 minus 0, we have negative 1 over 12 for our slope. And of course, using the first point, 0, 3.5, that would be considered a y-intercept then. And there's my line. This would not be considered a good best fit line is because all my data points are below that line. What I would really like to do is to have half the points above the line, half the points below the line. So I think a better option here is to use these 2 points right here. well, let's see, it was 1, 2, 3, 4, 5. That was the 6th. I think the 6th and that 8 and 2.54 right there. Those are the two good points to use. So 2.54 minus 2.84 all over 8 minus 5. That gives me negative 0.3 on the top, 3 on the bottom, or a negative 1 over 10, or as a decimal, negative 0.1. Now, I don't have a y-intercept here. When I line these two up, I don't have a y-intercept. So what I would have to use then is point-slope form of the equation of a line, which is basically, it's the slope formula moving over your x's. So point slope is y minus y1, okay, that's 2.84, minus your slope times x minus your x sub 1, that's the 5. So I distributed, I added over the 2.84, combined like terms, there is the equation of my best fit line, which again, these 2 points right there, crossing approximately at 3.1, 2, 3, 4, somewhere in that area. Now this to me would be by far a better example of a best fit line because I have 1, 2, 3, 4 points below the blue line, 1, 2, 3, 4 points above the blue line. That would be a better representation of that data. All right, so that's how we do it by hand.